This one is critical, needs immediate evacuation.
Strapped to her wrist was a ruggedized tablet, an edge device running a sophisticated AI-powered triage application. As she moved from one patient to another, she quickly attached a series of wireless biosensors to each individual. These sensors immediately began collecting a stream of vital signs: heart rate, blood pressure, respiratory rate, and oxygen saturation. Instead of manually recording this information and trying to calculate a trauma score amidst the confusion, Anya tapped the screen of her device. The AI, running locally on the tablet, instantly analyzed the incoming data. For the first patient, a man groaning with a visible leg fracture, the AI processed the vitals and, using a pre-trained machine learning model, cross-referenced them with a massive dataset of trauma cases. On the screen, a clear, color-coded assessment appeared. Stable. Suspected femur fracture. Monitor for shock. The AI had triaged him as a lower priority, allowing Anya to move to the next, more critical case. Her next patient was a woman who appeared unconscious. As the biosensors began transmitting data, the AI detected a dangerously low blood pressure and an irregular heart rhythm. A flashing red banner appeared on Anya's tablet with an audible alert: critical. High probability of internal bleeding. Immediate evacuation required. The AI also highlighted the most critical data points that led to its conclusion, providing Anya with the concise information she needed to act decisively. With the AI's rapid and accurate triage, Anya was able to quickly identify the most severely injured patients, prioritize their treatment, and radio in a clear and concise report to the incoming medical helicopter. The Edge device, with its onboard AI, had turned a chaotic and overwhelming scene into a manageable and efficient emergency response, ensuring that the most critical patients received the life-saving attention they needed first. This is a fictitious scenario, but one that we can all relate to and easily understand: a human needing to make sense of large amounts of data coming in from edge devices. This scene with Anya working through a first responder emergency situation is based on the real-time needs for medical triage. But echoes of the needs in this scenario carry over into many other domains, including the intelligence community, where similar edge AI challenges can be found with imagery, language translation, geolocation, cybersecurity, and financial transactions, to name a few. It also captures the two main themes of interest for our 2026 call for research using Edge AI. The first theme, intelligent data triage, can be seen in the speed at which Anya can move through the patients. The AI Edge device is not only taking in data in real time, but also processes the data intelligently, either locally with onboard models or as needed, using a connection back out to a server at the core. The scenario also describes the need for the AI to be user-centric, our second Edge AI theme, described by the AI being able to move with Anya from patient to patient, adapting to the new emergency case flexibly. Collaborative research in Edge AI is burgeoning across several key frontiers, demanding a multidisciplinary approach to unlock its full potential. At the LAS, a primary area of interest lies in the design of software models in situations with many of the same constraints as in the medical triage scenario, where researchers from academia and industry partner to create lightweight and intelligent AI models that can run autonomously on resource-constrained devices, or send data across a distributed network as compute power and bandwidth necessitate. Areas of highlighted interest include lightweight ML model development and optimization. In the scenario, the scene is set at an emergency situation that could happen at any location, so the devices Anya uses need to be lightweight and mobile, such as phones or tablets. Such small platforms are constantly balancing trade-offs between model accuracy and performance and navigating trade-offs in computational complexity, memory footprint, speed, and power consumption. For LAS research collaborations, expertise in areas such as TinyML, machine learning technologies, and applications capable of performing on-device sensor data analytics with limited power are ideal. And the edge can mean different things in different contexts. For LAS interests, we're targeting the edge as a general laptop type of device in bandwidth-starved environments that make transmission of large amounts of data prohibitive. Adaptive data management and intelligent filtering. For Anya, much like our IC analysts, models that can smartly adapt to the case she is working on at that moment while simultaneously understanding the totality of the emergency and being able to prioritize accordingly are critically important. LAS is seeking experience developing techniques for dynamic data filtering, aggregation, and summarization at the edge based on user objectives and/or anomaly detection. Key research challenges of particular interest for data management and filtering include developing models with less data that perform with improved accuracy and/or speed. Federated learning and distributed AI. In critical emergencies that experience many casualties, having a distributed device network that can share not only data, but available compute power is a powerful strategy for speeding response time and minimizing human lives lost. Similarly for the IC, this is a powerful strategy for responding to world events and getting critical information to decision makers as fast as possible. For the lab's 2026 research, we are seeking experience in designing and implementing frameworks to train, adapt, and deploy AI models across multiple edge devices without centralizing raw data. Applications of Edge AI. The challenges don't stop with model development, however, but also finds complexities in deploying and managing Edge AI applications. Our fictitious narrative demonstrated these Edge AI challenges through the perspective of Anya as a first responder, while LAS needs are anchored in intelligence and national security. But the ubiquity of small edge devices echoes these and other similar challenges across a wide swath of domains. Other example domains include emergency response, such as the scenario described in the beginning of this video, industrial IoT and predictive maintenance, smart cities and traffic management, wearable devices and healthcare monitoring, smart agriculture, autonomous vehicles, environmental monitoring, security systems. Regarding modalities, looking at the introductory scenario, the AI triage model used many different health monitoring sensors, along with an assortment of metadata types, the simplest example being timestamps. The LAS is interested in edge applications that continue to examine modalities of interest in previous years, namely audio and video, that also continue to factor in available metadata, which could include a range of data including but not limited to time, geodata, weather, and more. The breadth of domains using edge devices is proof that the future of intelligent technology is not just in the cloud, but right here, at the edge of our networks. The pioneering research interests we just explored, from the fundamental synergy of hardware and software co-design to the critical imperative of privacy-preserving AI and the cross-disciplinary collaboration needed for real-world impact, are the essential building blocks for the next wave of innovation to inform analysis and sense-making of data. By fostering collaboration in these key areas, we move beyond theoretical problems and begin to architect a future where intelligent devices are more efficient, secure, and seamlessly integrated into our analysis workflows. The journey to unlock the full potential of Edge AI is a shared one, and as Anya's triage work to make informed decisions quickly in an emergency shows, the technologies we are helping to develop in LAS 2026 research could already have a critical impact today.